Welcome, my name is Robert Magee. I work at Side Effect Software in Toronto, and I'm here today to talk about Houdini under the hood, which essentially is technology such as Houdini Engine and our new PDG technology, which I'll give you an introduction and talk about how it can work for you in game development. So, above ground, we have applications like Houdini itself, which can create game art, Unreal Engine, and Unity. And the idea of under the hood is us to take applications such as Houdini Engine, which we have plugins available for Unity and Unreal, and they can be running procedural systems underneath that, and also PDG. PDG is specifically designed to work with parallel processing, either on a multi-core machine or on the farm or on the cloud, and we're going to talk about some of the ways of setting that up and the benefits of that. So let's just do a conceptual overview. So Houdini is a node-based procedural solution. What that basically means is that everything you do in Houdini creates a node, and those nodes get connected into networks, which essentially become recipes for how to solve a particular problem that you're doing. What's nice is you can edit parameters and so on the different nodes, and you can get a unique result. Now, as we've evolved, Houdini has evolved, people got to this point where they said, well, these recipes are great, but we don't want to give the whole, 3 nodes, could be 500 nodes. We don't want to give 500 nodes to somebody and confuse them. So what we did was we created another solution where we could take those networks and collapse them into a single box into something we call a Houdini digital asset. Then what we do is we take the nodes down below and we take important parameters that we think an artist might need, and we promote those up to the level of that digital asset. Now, once you have that, you can go back into Houdini and it can act just like one of the other nodes in there. Essentially, it's almost like you wrote a plugin for Houdini, except it's done interactively, it can be done by an artist, but it becomes an equal partner to what Houdini is and what Houdini is capable of. The other thing that's nice about it is it sits on disk. So you reference it in. So if you have a digital asset referenced into a whole bunch of different scenes by a whole bunch of different artists, and then you want to update that asset, everybody gets the benefit of the update that you make. So that's a huge advantage when it comes to solving pipeline issues and getting things to work. Now, somewhere along the way, when we started getting into the game development side of things, people said, well, what about putting it into game engines like Unity and Unreal? And the solution for us there was a technology called Houdini Engine. It's an API that allows anyone to write a plugin for another application. So there's a plugin for Unreal, and there's a plugin for Unity. There's also one for Maya, Cinema 4D, and the API is actually available if you needed to write it for a custom game engine or some other solution. It's fairly easy to write a plugin for that. So what happens there is that you can take one of these digital assets and load it into a host application, let's say Unity or Unreal, and those parameters that we promoted at the top become available for you to slide and work and make the asset. So you're getting access to the proceduralism under the surface, and then you're able to make it do whatever you want to do. And I'm going to demo it, so you'll get a chance to feel that. Now, the next technology that I'm going to talk about today is this new technology we call PDG, which also in Houdini is a new context called task operators or TOPS. And the big thing about this technology is that it is designed for parallel processing and allows you to scale up a solution into a much bigger sort of pipeline solution. Often people refer to Houdini as a pipeline in a box. Well, PDG takes that box and sort of blows it wide open and says, okay, we're just going to go take over the whole pipeline. And it has that potential. Now, what's neat about all this is you get these 3 things that we talked about, the networks, the digital assets, the PDG nodes, and this is where it becomes very multi-layered. You can take all of that, wrap that up into its own box, and make a new digital asset out of it. And now you can have all of that going inside your Unity and Unreal. Now I'm highlighting Unity a little bit more here because we actually have a very specific PDG interface that's in Unity that hasn't quite been ported over to our Unreal plugin. So I'll be showing you Unity today, where once you get in there, you get really close access to specifically the capabilities of PDG in that environment. And of course, when you're doing PDG, that means that you can have an asset inside Unreal or Unity that is going off to the farm and taking advantage of nodes on the farm to parallel process stuff and bring it in and get you the results as fast as possible. So the first thing is, let's go back to Houdini. I mean, how many people here know Houdini? Work with it? Okay, so this will be a little repetitive for you, but in case there's anyone new here, they can sort of get a feel for this. So what I'm going to do is I'm going to build a single building, and just like everything in Houdini, it creates these nodes, and I've got a grid node, and I'm going to make some channel references between some pieces here, and this allows me to, if I want to tinker with the size here, I always get a nice grid along the two axes. Now, I'd like to create some columns for this. So the first thing I'm going to do is I'm going to create an inset, because I want to inset the columns in from the corners. So I'm going to use the poly extrude node and inset, and that gives me my new piece there. I get rid of the sides because I only need the top face when I do that. And you'll notice that the grid and the poly extrude I just created both have established nodes in the network. And now I'm going to start putting nodes into the network myself and start wiring them in. So I'm going to put in a tube, which uses my column. And I'm going to just put a couple simple expressions in to make sure the column is sitting on the ground. And then I'm going to do a copy to points. So I can take the columns and put one column at every point of the graph. Get rid of the transforms there so they're pointing up. So that looks good, although I don't want columns everywhere. I just sort of wanted the outer ring of columns. So what I can do is go back, and you notice how I can select a node even if it's up in the chain and still do stuff with the results of that. So I'm able to select the edges from that poly extrude node and just delete them to dissolve that, and then bring the inline points back, and I've got my columns. So you see there's a flow of data here, the grid through the poly extrude dissolving into the copy to points. So now I'm going to take the same original grid and I'm going to poly extrude it out to create a floor slab. And we're going to, in that case, we want to output a front and a back, so we've got geometry on both sides. And then what we can do is we can take that and we can transform that up so it will basically be sitting on top of the columns that we created. Then we go add a merge node down and flow this back together. And there we go. We've got one floor of our building. So everything in Houdini has nodes. We're going to put down another node, copy and transform. That will allow us to take the whole combined piece that we have there, and we can scale that up. And there's an option on there called pack an instance. So if you want to set instancing up, you can click that. I probably should have clicked that, but this is a simple example, so I didn't worry about it. But the copy and transform allows me to create multiple floors, and I can easily manage that and set that up. So here you see a bunch of nodes in Houdini. They've created a flow of data to get me an end result. I can go back and make changes and get myself a slightly different building if I want. But like we said, the thing that would be nice now is let's make it into a digital asset and take advantage of Houdini Engine to get that into Unreal. And there's two things that we're going to get out of this. One is to see how to get it over, but the second thing is, turns out the network I created isn't quite as procedural as I'd like to think, and we're going to find out some of the mistakes I made that have to be corrected in order to make it procedural. So the first thing we're going to do is we're going to get ready for game art. So the first thing, fix our normals, so they'll go over into the game properly. And then the second thing, we're going to put a group on here called rendered collision geo. And this will ensure that all my geometry will act as collision geometry when I get it into Unreal. So those are two things that are important to get ready to go into the outside world. So now I'm going to take everything there, select all of those nodes, and I'm going to go and make a digital asset out of that. I'm going to call it make building asset. And I'm going to come over, and this is where I could build my interface, but we're going to get to that in a bit. So now I've got an asset, a digital asset with my nodes underneath, and I'm going to go into Unreal and I'm going to load that into my scene. Now when I first bring it in, I can scale it, I can position it, but I don't have any of the proceduralism that's in Houdini. I don't have access to it. It actually is here, but I didn't build my interface yet. So until I build my interface, this is just a static asset like you'd get from any other 3D application. So we need to go back to Houdini and we need to make this more procedural. Now notice the collision geometry works if I bump into one of the columns and it's there. But I want to make the building taller. I want to play with the different aspects of it. So what I need to do is bring up the type property window. And this is where I can go and build my interface. So I'm going to start with this copy and transform. And I'm going to bring up an attribute for number of floors. Notice how I can give it a more friendly sort of artist name, something specific to what the asset needs. And so all of my names for that I promote can be easy to read in this situation. And I'm going to bring over the size. So this will be the floor slab size. So I've got some parameters, so that's great. I'm going to accept that. Now what I want to do is quickly jump up one level and test it here in Houdini to see how it's going. So yeah, that one works. Oh, that one doesn't work. Okay, what's wrong with that? I need to go back and figure out why that's not doing what it's supposed to. And the reason is because when I first built this thing, I did a lot of it by just typing in numbers and so on, and I haven't built the proper relationship between the different parts. So if I go into here, I'm driving the height using that transform node. So I've already got that as a sort of main driver. So if I copy that parameter, I can put that into the height of the column. So that will make sure the column falls along. I can also put that into the copy and transform that attribute there. So now all of these will follow the same attribute. And so when I move that slider, everything should work fine now. So if I go into there, yes, that's doing what I need. Perfect. Now, if I go in and let's say, change my floor slab, and I go like this, you'll notice that this isn't working. The columns are not on the outer rim anymore. They're sort of wherever they want to be. And the reason is because when I dissolve those inner edges, I dissolve them by hand. And so it's a very specific set, specific numbers. So I need to make that more procedural. So the way I'm going to do that is using groups. So I'm going to start with this, and I'm going to say, give me a group of all of the edges. And I'm going to call this remove edges. And I'm going to say, give me all of the edges. Then I'm going to put a second group down. And this time, I'm going to give it the same name. And I'm going to say subtract. And I'm going to scroll down, and I can say, give me the edge boundary ones. So I'm going to subtract the boundary ones from the ones in the center. Now when I go to the dissolve node, I get rid of my specific selection and say use that group. And now if I go one level back up and I start tinkering with the size, you'll see that at first I should save the network. Anytime you make network changes, you got to save that to that file on disk. And the other thing I want to do here is just play around with some of the slider options. So like for instance, the height has -1 to 1. Well, I'm not going to do that. I want to go 1 to 10. Or 1 to 2, sorry. For the number of floors, I might go 1 to 10. So I can actually craft my interface right here at this level by playing with that. And we can save that, go back up one level, and now if I play with that, everything's working fine there. If I play with that, now I've still got the outer ring of columns instead of there. So there's always, when you're making something procedural, these little things you got to do to keep it from sort of as a coherent system, something that you can take back into, let's say, the game engine, and you go and select that there, and you say rebuild the asset. And now you've got the interface. You've got the number of floors, you've got the floor heights, and you can manipulate that right here in the game engine. Now, first question everyone asks is, can I get access to those controls when people are playing the game? You know, can I have the character, set the number of floors or whatever? No, this is not a runtime solution. This is something for inside the editor to help artists build levels and create game art. It is not at a runtime thing. Yes?
Is there any thought towards having that available?
Yes, but if we gave you all of Houdini, your game would be probably maybe a little too heavy. The next thing I've got is I wanted to go in and add some more details into this. So I'm going to go in and I want to be able to go up into the building. So I'm going to put a hole into the slab, and I'm going to use that hole to cut an opening using our new Boolean tool. Well, relatively new. It's probably a couple years now, but can take that and we can say do a subtract. So that gives me my opening. Now, notice that when I'm making modifications, I can say, look at the end of this. But then what I can do is I can select one of the earlier nodes, and that will give me access to select a face on that first slab while it was still down on the ground. Then what I can do is I can say, let's poly extrude that. And I'm going to do it out, and then I'm going to move it down. So I'm seeing a wireframe of where it was earlier in the chain, but I also get to see a shaded view of the final result. So it helps me make a sort of creative decision here. Now, if I want to be a little more accurate about this, I should also make some of those simple expressions to link some of this stuff together, so that the floor height's done right and some of the other aspects are done right. So that's always a good thing to do. And then once I have this, now I have these ramps that actually go up and will go up into the space, and I can use those to have my character walk upstairs. So let's just save that just like we did before. And then we can go back to Unreal, and we can select the asset and rebuild. And now when we press play, well, we might just want to play with the floor height a little bit. Again, we've got all that control of that here. Press play, and now we can go walk around that building. So go there, we're going up the building, and it's a little tight and cramped in here. And now you see one of the benefits of digital assets, because if I had modeled this building and given it to someone, they would have to go back and ask for a new model. But because this is a procedural asset, you just go back and play with the floor height, get it the way you want, and boom, go back and test it. So a procedural asset can really help in the level design process because it gives the level designer flexibility to tinker and toy with these things to get exactly the result that they want. So that shows you, so we've looked at the first place where Houdini can work under the hood. It's the proceduralism is inside this asset, and you're taking advantage of it here inside your editor. And I could have taken the same thing into Unity as well, and it would have been a similar experience. So the next thing I'd like to do is a city building workflow. We won't touch Houdini Engine at the moment. We'll come back to that later. This is going to use the new PDG. Now, PDG stands for Procedural Dependency Graph, and I'm going to go through a little bit of an explanation as to what that is before we go and see it in action. The key is we're going to take that 2D image of a city grid, and we're going to turn that into a procedural city. So in PDG, we're going to use these things called task operators. And when they first come up, they look very similar to other nodes in Houdini, but they have a very distinct difference. And the difference is when you first cook them, you get all these little dots. And what happens is these dots represent what we call work items. So when a node is processed, it says, well, how many things are you asking me to do? So in a city, it's like, well, how many buildings do you want me to build? Okay, it looks like you want 80 buildings. And I will go and process those buildings one by one by one by one by one. So in this case here, you see the little spin wheel, and at the top it says that there's 7 completed items, there's 3 in progress, and there's 70 in the queue waiting to happen. And so they'll chug through, and then when you finish, you get a nice little check mark to say, yes, we've accomplished the task. All the tasks are done, and this node's ready to go. Now, of course, there'll be many nodes in your network, and each one of them will be going through this process. Now, what's interesting about PDG is because it can manage dependencies, you don't have to wait for one node to finish for the next one to start. Because as soon as the dot in this one that flows into the next one is ready, the next node can start to do its thing. So you watch more of a spreading out of the tasks as opposed to just a waiting game of one node after the other. For anyone who uses Houdini now who's maybe used some of the dependencies in ROPs, well, that's always been our problem there, is in ROPs, you got to wait for one ROP to finish its job before ROP 2 can go do what it wants. So in some ways, you can think of task operators as ROPs on steroids, capable of doing so much more. Now, one of the other key aspects of the procedural dependency graph and where these dependencies come into play is, is the fact that you can scale up by distributing. So if you look at the second thing on the list where it says 3, the reason it says 3 is because I'm doing it on my local computer that has 12 cores, and by default, it divides those by 4. So I got 3 cores on my machine doing all the work. Now, I can bump that up, so I could say give me 8 or 10 of my cores on my machine. That would be better. But if I can access the power of the farm or the cloud, I could bump that number up to 100 or 200 or 500. So this is where we break things wide open, and we stop being sort of constricted into the Houdini network, because now we have access to a larger compute farm to do more. The other thing that's really neat about it is, let's say I come along and I update my scene. Something's changed. Well, what happens is the PDG network can analyze that and come back and tell me that with the change you made, 21 of those items are still good to go. But 59 of them, they need updating. They need to be recooked. So this comes into the concept of a dirty work item and a clean work item. A dirty work item has to be recooked. It has to be recooked to get to where you want. So you go through and you press play, and it will start from 21 and finish all the items from there. And I'm going to show you an example of that later in the demo. But that's a key component because, the examples I'm going to give you, the buildings they process pretty quickly. But if we were dealing with something way, way, way more complicated, you do not want to reprocess something that doesn't need to be reprocessed. So having that benefit is huge. So I'm going to take you through the whole process of building this city, just so you feel all of it. Here we bring in the city graph. We use a trace SOP to trace it, to get the actual, turn it into geometry. So it's turning a JPEG image into geometry. I'm going to transform it to rotate it so it's lying flat. Turns out the normals aren't in the right direction, so I'm going to put a reverse node down just to make sure the normals are pointed up the way I want them to. And then you can see that there's tons of dots in the tracing process. So I'm going to use a resample node to go around and reduce the number of points around the edges. So this just cleans it up, makes it work a little bit nicer for me. So then I'm going to put a null object down so that this network has a clear out. I like to put that all in caps and say city blocks out. And we will use this to create our first top network. So you just press tab and you get this top network. And it's a new context which we can dive into. And one of the things I like to do is I like to keep two networks open and locked so that I can more easily go back and forth between tops and other networks that I want to play with. There's a couple gotchas with it, but for all intents and purposes, this seems to work quite nicely. So I've got my top network over here. I'm telling it to import geometry from this particular SOP net that we have out there. I'm going to get the primitives from that, and we're ready to go. So we'll cook our first network. So we just right-click on it and say cook, or you can do Shift-G. And that was pretty quick because it was an easy process. And if you click on these little work items, they'll tell you what the name of the file is. But we want to visualize that. So we're going to put a file node down and we're going to go view work items. Now, if we go down here, let's add a color node so we can distinguish the work items from the city blocks that are already there. And what we'll do is first we'll go and we'll find them because they got put on disk. So if we move through time, there's all the work items. But we don't want to attach it to time. We want to attach it to the top node itself. So we're going to replace that with an expression which is backtick at PDG output backtick. Once we get that, as we click on work items in the top node, we will see them displayed in the viewport. And that is, so this little viewer is like a little utility that I keep around as I'm working with tops to make sure I can always come back and see what I'm doing and make sure I can see how it works. So the next thing we do is we want to extrude these into buildings. So we're going to need some height there, and we want to allow the height to be generated in a random fashion. So we're going to create a height base which of 10, so all buildings will be at least 10, and then they're going to have a random, using the PDG index. Each PDG item has an index number, and we're going to multiply that by, let's say, 15. And if I go and I cook that particular node, it really does nothing more than apply those parameters or those attributes to the geometry. So I can middle click on it and I can see, you can see the values in that middle click. You can control middle click if you want that window to stay open. But so great, I've got my parameters and now I want to use them to make a building. So the node I'm going to use for that is called ROP geometry. And this node actually has a SOP network in it. So we'll be taking advantage of that. But first what we want to do is we got to set up some things. Don't use an external SOP. And we're going to generate the work items. The work items exist, but nothing's been cooked yet. So we dive in and that work item we can actually visualize. So there's that one work item. And we can use that to help us visually build the building. And we're only going to be building one of the buildings, but that will be the basis to ultimately apply to build all the other buildings. So we're going to go in and add a poly extrude. This first one will be to create an inset for the sidewalk, because we don't want our building to be covering the whole city block. Then we're going to put another one down to create the building height. So in this case, we're going to go and, I'm going to put a fuse node down ahead of it, because sometimes when you inset, points get a little too close together and that doesn't make for a good building. So we're going to fuse those points. So now we're going to go into the distance for the poly extrude, and we're going to use those PDG attributes we created. So at base height plus at height variation. And there we go. And now that's poly extruded our building out. So now we're going to take the height distance and we're going to put that into the divisions and divide by 2 just to get some sort of windows sort of set up there with 2 meter high setups. And we're going to set a couple groups out. One for the front and one for the side. We're going to give those names. Now this is part of that procedural thing that we did back when we were making digital assets before. Group names give us a lot more flexibility to have different buildings being produced with different city blocks. So this part gets a little fiddly, but I think it's worth going through just to get a feel for it. You don't need to follow every step because it's all written in a tutorial that I'm going to tell you about later. So you don't need to write it down or anything. The next thing we're going to do is we're going to extrude out the window frames. So we'll set the display flag down here, and we're going to just set a small little distance on there. We're going to use the side of the buildings, and we're going to go 0.05, and that'll create our windows. Great. And then again, we want the output of that to be something that we can use down the line. So we're going to call this window out. And then we'll put another node down to deal with the extrusion of the window in. So that one is, I like to keep things named, and now we're going to use windows out. We're going to put a distance in here, and then there we go. So we get in there and we see we've got our windows sort of being set up like that. Now, buildings, when you see them in a city, they also look good if the top of the building has a little parapet. So we're also going to set up that. Now, of course, the actual building you build for your city building is going to be way more sophisticated than this, but it's just going to be, instead of my 15 nodes, it's going to be your 500 nodes. But philosophically, you're going to be doing very much the same kind of thing that we've got here, creating opportunities for things to be generated in a procedural fashion. Now I'm going to put another node down for the last one. This will create the parapet itself. And again, we take advantage of these procedural groups that each node generates, and that will give us the parapet. And one last node we'll put in. This will add the color into here. So this is just going to put sort of a dark gray, and we'll just put that specifically on windows. So there we go. Our windows are dark gray and everything else is there. So perfect. So now that we have that, what we can do is jump back up to the PDG level. And the next thing we have to do, again, a little fiddly, but it's sort of important, is we don't want to be doing this based on frames. So we're going to do it based on PDG index. So the index will determine each building will be sent out, exported out based on that. So we can generate that. We can save that and generate that, and now the buildings are going to be generated. Now, you notice that the second thing says 3. So just like I said, I have 12 cores. By default, it uses 3. So I'm going to go to the scheduler, and I'm going to set the maximum CPUs to 8, just so I can take advantage of a couple extra cores on my machine. Now, I have sped this up a little bit for demo purposes. It doesn't run quite this fast. For simple things, it's going to feel like TOPS is maybe a little slower than if you did it in SOPS. But once you start scaling up, then it's no comparison. The other thing that's very important with PDG is to always start small. Test your ideas small and then scale up. Because if you're trying to test them big, then it gets too complicated. So now that we've created all our buildings, we've got a partition node called wait for all that brings them all together, and then a geometry import that will merge them all into a single piece of geometry, which we will save onto disk. So we're going to call that building merge. And it's got dynamic settings, so it should be all set ready to go. So we take that and we cook that. Now it sort of forces us to save each time. Got our checkbox, we're ready to go. Click on that. Now it looks a little weird right now, and the reason is because we're still inside that geometry, ROP geometry node. We got to go back up to the object level. And looking like something's wrong. For some reason, my buildings don't seem to be starting at a base height of 10. So I got to go back and sort of debug it and figure out what's going on. So if I go back to here, I go back to my building height, and I've got base height plus height variation. So that's what I wanted. So let's go back to the up a level to the actual parameters and see in tops and say the actual attribute, that I created. Oh, I gave that one a different name. It should have been base underscore height. Now, that means that that node is wrong. It's got the wrong information on it. So I have to dirty that node to sort of wipe it clean and then tell all of the other nodes to recook with that new information. So just like sometimes PDG will dirty up a work item or a node, sometimes you have to do it just to flush it and get yourself a new starting point. And now it'll go through, run through the things, and there we go. Now we've got our city doing exactly what we wanted it to do. So this is fine, but I mean, like I said, if you're a Houdini user, you probably could do this in SOPs, and you don't see the benefit quite yet. But what we're going to do is we're going to do some other things here to flesh this out. And what we'd like is we'd like the city to have a core, a very specific place where the city core is. So the way we're going to manage that is way back on the city grid. We're going to put the color, we're going to put some black on the item, on all the primitives. And we're going to do that specifically to set a base of 0. And then we're going to put a sphere in the middle, and we're going to add the color green to it. And then we'll do an attribute transfer over to create an area that we can call the city core. And the reason we're doing it this way is so we can have parameters attached to it, and we can take advantage of those later when we try to create some variations for the city. So we're now going to use an attribute transfer on this. So we go in, we attribute transfer. We got to make sure, oh, that's not quite right. We need to make sure that's set to primitive. Then we go through and we say we're going to copy over the color, and we're going to set a threshold of 0 and a width of 30. So this, you can see, has very bright green in the center and sort of falls off. Now what we can do is we can go back to that attribute where we created the random variation on the building, and we can say add in the green color times 30 or 40. I think I did 40 in there. And again, because that's going to ruin what's going on in that node, we got to dirty that node and then go back to the end of the chain and cook it all again. And while we run through that, we should see at the end of that process a city with a specific core based on the position of that sphere. And there we go. So here we are. We've been able to make this city using this technique. And if we go and take that sphere and move it, this is where we come across the thing we talked about earlier. So we take that and we say, okay, that's in a new position. So let's go into the PDG, and instead of cooking, let's just generate the nodes and see what happens. And this is where it can go through and discover which nodes are affected by that change we just made. And if we sort of blow that up, what you'll see is that some of the things say they're ready to go and some of them aren't. And that's because some of them are dirty and some of them are clean. So now you can go in and you can go back and say, let's recook it. And instead of recooking the whole thing, it's only going to recook those things that were designated as dirty. So it will come in faster. And now we've got the core off to the side instead of there. Okay, so the next thing that we want to do is say, okay, we've got the city building, we've got one of them, but we're not sure if this is what we want. We want variations. When you're in the design process, it's great to have lots of variations. So what we're going to do is we're going to use a technique called wedging. Wedging allows us to put parameters in and say, you know what, randomize some parameters and try these different things. So we're going to actually try 4 city maps, and we're going to randomize the position of the city core, and we're going to randomize the seed on the variation of the buildings. Now, we're only going to create 4 of them, but once we got the system set up, we could easily create 24 of them or 36 of them and whatever. And then we could render them out with little notes as to which parameters we use so that we could evaluate them and decide which of these do we really want to use. So this can be extremely powerful to create an automated sort of variation and iteration system so that you can get feedback and get directors to say, hey, that's the one I like, that's going to do what I want, et cetera, et cetera. So in order to make this work, the first thing we're going to do is take that city grid thing that we had before as a separate SOP network, and we're going to wrap that up as a digital asset. That will allow us to get it into TOPS specifically, and then that will give us easier access to the various parameters for wedging purposes. There's other ways to do it, but this is it's important to note that digital assets can become a part of the TOP workflow. Again, it's assets working under the hood of TOPS, just like it works under the hood of engine or of game engines. So we're going to drag over and build an interface that includes the image that we want to do. We're also going to bring over the uniform scale. That's one thing we may want to take advantage of in case we want to create a big city. And then we're going to also bring in the center. So this will be the position of the city core. Once we have that, we can accept that. That'll save that to disk. And then we're not going to use this SOP network anymore. We're going to go over to TOPS, and we're going to use a HDA processor top node. And we're going to use that instead to grab the HDA directly off disk. So we're going to wire that in. Actually, before we do that, we're going to go to the geometry import and make sure that it's not using the SOP network, that it's dynamic, and that it's using the node ahead of it. So now we can go to the HDA processor. We can go and get the new HDA that we just created. And once we do that, you can see the HDA parameters get loaded in, and we'll be taking advantage of those in a second. And we go make city grid, and we're good to go. Now, just to be on the safe side, my first instinct is to go and retest the graph because I want to make sure I didn't make a mistake when I built the digital asset. So run the graph, make sure that the city that I'm generating is the same one that I had 2 minutes ago with the other setup. And I go in and yeah, looks good, looks good. So now to create the wedging, what we're going to do is we're going to add another node on top of here called a wedge node. And we're going to create certain parameters in the wedge space, which we're going to use down below. The first thing we're going to do is we're going to create 4 wedges. And we're going to create some attributes. So the first attribute is called center wedge. So this is for dealing with the center, the city center. So we're going to range from -50 on one corner to 50-50 on the other. So that means the core could be anywhere within the 100 by 100 grid. We won't deal with anything on the height direction. Now, once we have that, we can then go to this center here and put in add center wedge .0, .1, and .2. And that basically will say take the wedge values that you create, which we said to randomize, and use those in this context. So that will take care of the center, the city center moving around randomly. Now, the next thing we're going to do is add a new parameter, and this is for height variation. It's more height variation. So we're going to take the seed of the randomization, and we're just going to add new numbers into there. So we're going to go anywhere from 0 to 1,000. We're going to randomize that, and then we can go down to the to set that up into there as well. So you just, once you've got these, once you create a wedge, you got to go and insert it somewhere into your network so it contributes to the end result. If you don't do that, it doesn't know it exists. So we added that in there. I think that would allow us to do one crack at this. And, little fiddly thing we have to do at this point. Because we're going to create 4 different versions of this, we need to be able to identify them later when we go to pull them back up. So we're going to add into here a little expression called backtick at wedge num. And we're going to add that to basically any place we're saving stuff along the way. We've got to add that in, because otherwise we're not going to know whether it's associated with map 1, map 2, map 3, map 4. Like we don't know what the results are. Because whereas before we were creating about 73 work items, we're going to do 4 times that now, because we're doing 4 wedges. So they have to be identified. So that's a little bit of a, copy paste, copy paste, copy paste, but you will get that. The other thing we have to do is when you finish that, we got to get rid of this wait for all, which is designed for sort of a single stream of things coming together, and change that for a partition by attribute. And in this case, we're going to change it to distinct attribute value, and we're going to make that attribute wedge num, which is the thing that we added in earlier. So it will be able to find the wedge num attribute and then appropriately do what we have to do there. So we're going to save that, and then we're going to cook the node, and it's going to go and do its thing. And I've definitely sped this one up because it was doing 4 times the work. And now you'll see that we have 4 different results here, and you can cycle through those 4 different results, and they have different city cores and different variations on the buildings, and that's sort of fun there. Now, the last thing we're going to do is add one more attribute here to get those different maps, because we had 4 different city maps. So the way we do that is add an attribute called file wedge, and we're going to do that as an integer number going from 1 to 4. So this one won't even be random. We're just going to get 1, 2, 3, 4. So it'll do this one in order. So it's a little different than wedging. And where we went to HDA processor to get that grid, what we're going to do is we're going to first go into that folder where the 4 different maps are, and we're going to replace $F with that at file wedge with the backticks. Don't forget the backticks. Now, once we have that, we basically have to dirty that node because that node has changed significantly. And then we can go back to the bottom and recook. I have my super speedy cooking. And once we get that, we will get our 4 variations. So now we will actually have 4 different maps with 4 different city cores and different variation and so on there. So that's the process. That's the process of using PDG to create something like this. And you could take this same solution to scale up. So this is an example of using a much bigger grid. And in this case, the buildings have the same floor slabs and columns that we sort of set up at the beginning of the demo, but now you've got the whole city that way. But of course, you'd take it even further, and you'd have different building types, and you'd have randomization of building types, or maybe the building type based on the height of the building, and this thing could very quickly evolve into a full, mature, exciting looking city. But PDG is a great sort of core to build that up and get that into your work. So the farm would obviously play a big part, and the cloud could very well play a big part once you start to scale up, because the parallel processing is one of the main features of PDG, and you don't want to forget that. So the last thing we're going to do on here is take that same asset and wrap it up as a digital asset and put it inside of Unity, so that you have the same sort of capability we just had, but you have it within the Unity environment. So the asset, I already built the asset, so I'm just going to show you what we have there. It's got some of the same parameters that we had before. It's got a couple extra ones. It's got a little stand-in geometry waiting, because just waiting for you to build. And in the top network this time, we got rid of a bunch of nodes. We're not doing wedging in this one, and we got rid of some of the end nodes that aren't necessary when you're in the plugin, because it can take the HDA processor and just populate with that. So it's a little simpler to set up. Now, once we have that, we go into the the Unity Engine, and we can load the digital asset, which is the city topnet, put that in there. And then what you do is you've got the parameters we need there, but you can go up to the top and say, give me this PDG link. And you get a nice little interface on the side that is aware of work items and the idea of work items that are in progress. So we can go in and say, let's cook this, and you'll see as you watch the progress there. And this is the part that isn't yet in our Unreal Engine plugin, so you wouldn't get this nice feedback in there, but it will be coming at some point. And then that goes and processes the building and sets them up. And of course, the same idea of making changes and having those changes respect the dependencies. So if I go in and say, okay, let's pick a different map. Okay, in this case, every building's going to be new, so it's got to reprocess everything. But if I go and move the city core like we did before, then only certain buildings are going to have to be updated. So that's pretty exciting. So we can get in and get a feel for it, and there it is in there. And again, I mean, this is all stuff that, you know, I mean, you've pretty much seen everything that's in here. You've practically seen everything done live. So, you know, this is what you can do in an hour. Imagine what you can do, you know, with a larger selection. So the next thing I'm going to show you is another example of a system set up using PDG. This is actually Kenny, who's going to be giving the next presentation. And you can see that as he moves the road, only certain parts of his environment update because they're taking advantage of PDG's dependency aspect. So only certain parts of the landscape update, only certain elements of the terrain or the trees update, and that's all because PDG's under the hood managing this and getting this to work. So he'll be taking you guys into more detail of that, but I think it's definitely a great example of when you take this sort of to the next level. So of course the next question you have is, well, this is all great, but how do I learn to do it? Well, we have lots of great tutorials on the Side Effects website. We have a section called sideeffects.com/learn, which has a whole bunch of learning paths. So if you're a beginner, more advanced, if you want to focus on games versus visual effects, whatever, or PDG, we have a foundations guide to get started. And this whole city thing that I showed you here is available as a foundations tutorial for PDG. And Kenny, who's going to talk next, he's created a whole bunch of tutorials on his landscape stuff, which is up there as well. So tons of tutorials to get started and get a feel for what PDG, Houdini Engine, and how all this stuff works. Well, thank you very much. I hope that this has been helpful for you, giving you an idea of how PDG and Houdini Engine can work under the hood of your game engines. I think we've got a little bit of time for some questions. Are there any questions? Oh, and before I get in trouble, I will toss the box to whoever wants to ask the question.
Hello. When you're recooking items that have already been modified, how exactly does it check to see which items are different, like in the case of buildings?
Well, sure.
In this example, for example, if I went and redrew a part of one of the PNGs, is that likely to still kind of trigger recooking in the appropriate bits only?
Well, it's hidden underneath the graph that you see is the actual dependency graph. And when you click on a node, there wasn't really an example here to do it. When you click on one of the work items, these white lines get drawn up to all the things that came before it. And so that shows you how each item is aware of everything in its path. So once you dirty something somewhere on that path, it's very easy to go down and tell the other nodes down below, you're going to have to do more work.
Right, but in this case, the nodes are created in the HTA processor, and that's geometry one. So in that case, how does it know which ones are being created anew?
Well, because each building was specifically attached to a particular city block. So it knew exactly which city block it came from. And so it was able to, when it saw an attribute change in that particular city block, it said, okay, something changed there. We have to react to that change.
But you're rerunning the entire HTA every single time. So all the city blocks are created anew.
No, that's the whole thing about PDG, is what you did was when I did that generate, it went through and figured out which ones had changed and which ones hadn't. When you go and recook it, it will only recook the ones that it felt didn't need to be changed.
But how does it know which ones that need to be changed?
Because attributes didn't change on the, nothing changed in the incoming information. It's basically has an awareness of all the parts that are feeding into it.
So literally just comparing the geometry files and seeing.
Yeah. No.
Okay.
Yeah, it's good. It's pretty nice. It's efficient. Yes.
I noticed there was an attribute create top. I know there's also an attribute create stop. So like.
Well, it's funny actually. When I first set this thing up, I had an intern help me set this all up, and he said, "Okay, let's put the attributes in tops." And I went, "No, put them in stops." So we put them in stops, and he gave me the steps, and I started doing it, and then suddenly I went, hey, wouldn't it be better if we moved these into tops? And because the advantage of having them in tops, so there's two. One is you've got them all there, so you can just do your stuff in your top network. But there's also, we have a separate application called Pilot PDG. So if you set up a PDG network in Houdini, you can open it into this other app, Pilot, and cook it there. So you could have like a render wrangler cooking networks and generating stuff. If you put your attributes down at SOPs, that guy with Pilot PDG will not be able to touch any of those attributes. So the more you can do in the PDG in the top net, the more flexibility your render wrangler will have to deal with that.
Are there any other sort of secret top stops we should know about?
Oh, I don't know whether they're secret. Well, I mean, I think that there's some pretty amazing ones. Like you can, which a lot of them I wanted to use in here. Like there's one for bringing in CSV data. So you can, you don't have to add your attributes. You could have a CSV table and pull in all your attributes that way. There's one that will send an email out to people. So when your top's finished, you can actually email someone and say, go check the network out. There's connections to other apps. So there's actually a Maya top that will go and bring up a Maya and run it there. We recently had Adobe write one for Photoshop. So you can run Photoshop actions through here. Now that one's not available yet, but it will be soon. That's the other thing is, TOPS is not specifically just about Houdini. There are other parts of your pipeline that could well benefit from what TOPS has to offer that has nothing to do with it. And if you go to our website and look at some of the presentations we did for our PDG launch, there's machine learning examples that are not particularly Houdini related, and other things, other pipeline things as well. So it's a very versatile place to do stuff. And there's fun stuff. Shotgun, if you work with Shotgun for asset management, there are nodes for bringing stuff in and putting stuff back into Shotgun from right within PDG. So it is meant to be a full assistant to the pipeline process.
Can I literally throw this?
It's soft, don't worry.
I have two questions. I promised I wasn't going to kick that, and I did. The first one is, it seemed like there was a lot of steps where you had to manually tell the tops that they were dirty. Is that like an option to figure it out, or is that just kind of workflow?
Well, I think it was because I was adding stuff in that was completely changing what that particular top was doing. In that case, making the whole thing dirty just gave me a safety zone for that. Like for instance, an example was when I first put the attribute transfer in order to get that to, because I had changed the expression, I did have to dirty the whole thing in that case just to get it to accept the new thing. So during the design of a network, you will probably do a lot more of that manual dirtying out just to make sure everything's working. But once you've got the pipeline worked out and you're feeding data through it, then you'll be relying on that a lot less.
Does it have any detection to know when it's dirty, or is it always require you to manually?
Well, that's what I showed later when I moved the green over and I generated it. It was able to say some of these are clean and some of them are dirty. So, and when I was running it inside Unity, or the example that Kenny has, when he moved that bridge, it didn't regenerate the whole landscape. It only regenerated that one area because it knew that those were the only areas that were affected. So there is some real logic under the surface that makes that stuff possible.
Okay. And my other question was, you were talking about sending the processes to other machines. Is that, I know they said that that's not part of TOPS directly.
Yeah, what we do is we have a scheduler node. So the default scheduler is a local scheduler, so it just uses whatever cores you have on your machine. There's also a scheduler for HQ, which is Houdini's distributed solution. There is also one for deadline and tractor. And it's not that hard if you have your own scheduler that you use, you can write a Python interface for that pretty easily. So we rely on other software to actually go out to the farm and schedule the tasks. But PDG is the one sending the tasks out there. But it doesn't actually manage them on the farm itself.
Is it optimized? I mean, the tasks are very small, like so that you're not sending the file that's 10 gigs over to recook one.
Well, they might be. I'm getting the thing. I'm going to go out the back here, and if you want to finish up questions, we can talk about them out there. Anyway, thank you very much. Have a great day at the show.